Hello, I'm Terrence Jorgensen. I'm involved in teaching the methods and statistics courses in the Research Master here. And I'd like to introduce you a little bit to the types of research and statistics courses you can expect to take in our program. There's 3 courses that are mandatory, and it begins with the fundamentals of methods and statistics in educational research. It's focused very much on regression modeling. And we frame null hypothesis significance testing, how to conduct those in the context of a modeling framework. And the following courses sort of extend regression modeling in a couple of different ways. Multi-level modeling allows you to account for how observations are related to each other in some way instead of independent of each other. So, for instance, repeated measures of the same individual. Or measuring multiple individuals who are part of the same community or the same classroom, students within the same class with the same teacher, for instance. The third class you'll take is structural equation modeling, which it also extends regression modeling by allowing you to fit multiple regression models simultaneously. That gives you the ability to test some very nuanced different kinds of hypotheses, such as indirect effects, mediation models you may have heard of. Factor analysis is a special case where it's a measurement model. It's about evaluating how strongly scale items are related to the construct that scale is trying to measure. Growth curves allow us to investigate change over time. So the content of that first course, it will include some information you've already seen in bachelor level statistics, including descriptive and inferential statistics and how to visualize your data. And you may already recognize many of these methods, such as correlations, t-tests, ANOVA, but we frame everything as from a unified approach. These are all actually special cases of a single generalized linear model, and we teach the course from that perspective. So statistical modeling actually subsumes null hypothesis significance testing as one aspect of this modeling procedure. We begin with a theory. Something substantive that we can understand, no math involved, but we begin with that theory, and then we learn how to translate that theory into a model, a statistical model, and it involves learning, thinking carefully about our theory. How can we form a hypothesis that can be observed or not observed in data? And so we frame that in terms of a statistical model. What should we observe in the data we record if a certain hypothesis is true? And so we test hypotheses by then comparing models that represent a null hypothesis or an alternative hypothesis. And there's many different complementary statistics that inform all these conclusions. You can read more about the modeling approach at this citation I've provided here. But the model comparison approach really unifies what appeared superficially to be very different methods. So in your bachelor level statistics course, you may have learned about t-test and ANOVA as though they were separate things, correlations, but we really teach all these things from the perspective that it's really one modeling framework that we're interested in, and that allows that one modeling framework, depending on the details of the variables, allows us to test very similar hypotheses, but with different types of data. It provides a theoretical foundation for drawing inferences. So instead of reifying a p-value, instead of just sort of rotely learning how to conduct a statistical procedure and end up with this sort of binary decision of whether to reject or fail to reject a null hypothesis, we really focus on a set of information. The p-value is one of those pieces of information, but we have a set of information that gives us some supporting evidence or disconfirming evidence about our theory. And this approach we teach too in the fundamentals course, because it also applies to any other modeling framework you learn about. So you'll use this same model comparison approach to test hypotheses in the multi-level class and the structural equation modeling classes that you take following. There's, a lot. This sounds very esoteric. I hope it's not intimidating, but we do take a very practical approach. We have, of course, we choose textbooks that are accessible even without very technical background. So all of our lectures that introduce these methods. They're complemented with practical labs. So you'll essentially, during the labs, you'll work together with partners or a group of students, and you'll work on some assignments to conduct in class, and you'll turn those in and get feedback on those assignments. So you see how well they're doing, and we found that really facilitates student success with their take-home assignments, which you work on your own, and those assignments are graded. During the labs, you will work with real data to conduct the analyses that you learned about from the lecture and the textbooks. The data often come from articles that are published by researchers in our own department. So you'll get a chance to work during the lab, to work with data that resemble the types of data you'll encounter during your internships and your thesis projects. We use the R statistical package rather than SPSS, which has long been popular in social sciences. We have many reasons for using R. It has a more intuitive, more flexible syntax than SPSS does. It really encourages reproducibility because that's its basis. And it is free, as in free speech and as in free food, so it's openly accessible to anyone. It's also open source, which means that it's subject to peer review, just like research it goes through a peer review process. Software can go through a peer review process. We don't just have to trust that they're doing the right thing. We can actually break open that software and see when something is going wrong or make suggestions for improvement. All the teachers of your methods and statistics courses, all the lecturers you'll encounter, have experience, myself included, have experience contributing their own R packages to extend or introduce new methods in the R environment. So it's very versatile. Everyone can contribute, and it really puts you in touch with the entire global research community this way. It's very much the way of the future. So it looks very good on your CV at the end to have some experience with this program that's slowly taking a foothold, and faster nowadays is starting to replace some of the paid software programs in a variety of fields. So we hope that with this practical approach, you don't find the statistics courses too intimidating, regardless of the high level we teach as much at a practical level as we can. And we hope that you are interested in pursuing this program.